Today, you're going to be looking at ways that you could find a percent without using a model. So this video has two parts. The first part is going to be going over the exit ticket from yesterday. And in the second part, I will show you examples with percent equations. So yesterday you were given information about shoe prices at a department store and then shoe prices at a superstore. This question first asks you to find the constant of proportionality, remembering that constant is found by doing y divided by x. I started by labeling x and y in my table, and then I selected just this first row here. So to set that up, I'm going to do 16 over 20 because 16 is my y value and 20 is my x. When I divide that, 16 divided by 20, I get 0.8 or 8/10. And then it asks me to put that into an equation. Well, we know in the equation, the constant or the unit rate we just got, that subs in for the R. I am going to use some different variables besides x and y because when I have to use the equation to solve, it's going to help me better understand what's going on if the variables remind me of the labels in my table. So I start here with the x values in the department store. Rather than using x, I'm going to use D for department store. And then, everybody's telling me about the meeting. For superstore, I'm just going to use an S. So when I write the equation, first it says y. Instead of y, I'm using S for superstore. R the rate, 0.8. And then x value, instead of the x, I'm using D for department store. So what does this equation mean? Well, this equation is telling me that the cost of the shoes at the superstore are 8/10 of the cost at the department store. Your warm-up today had you converting decimals to percents and vice versa. What would 8/10 be as a percent? Well, we know to convert a decimal to a percent, we simply multiply by 100. That gives me 80%. So what this equation is showing me is that the superstore prices are 80% of the department store prices. Now let's use that to solve a few problems. Number 4 says, what is the superstore price for a pair of shoes that cost $28 at the department store? So I'm going to substitute in for department store the value $28. Any time that you have a variable next to a number, this is called a coefficient, this means to multiply. So the process here is that I am multiplying 0.8 times 28. And I still don't know the cost of the superstore. That's what this is allowing me to figure out. So when I multiply 8/10 times 28, I get that S, or the superstore value, is $22.40. Let's use that same equation to solve 5. What is the department store price for a pair of shoes that costs $15 at the superstore? So now, rather than substituting in for the variable D, I know the variable S amount. So 15 at the superstore equals 8/10, 8/10 of whatever it costs at the department store. So how can I solve this? Now, this is a skill that you may or may not have gotten last year based on if you did your online work in the spring. I'm going to show you how you can think of this in terms of a ratio table. If I have 15 and that's equal to 8/10 of D, solving an equation means I get 1 D. I'm trying to get the variable by itself. Now, 1 times D would just equal D, so I don't have to write the 1, but know that that's the process anytime you solve an equation. You want to get the variable by itself. The reason I'm looking at the whole number 1 here, we'll think back again to the warm-up. I'm trying to find 100% of the cost of the shoes at the department store. 100% equals 1 whole, so that's why that connects here. How would I get from having 8/10 of D to having 1 whole D? Well, I know any number divided by itself gives me 1. What that looks like in the equation over here, I could just show that I'm dividing this side by 8D, or 0.8, I'm sorry, got ahead of myself. And then I know that 8/10 divided by 8/10 is 1, and that leaves me with the variable isolated. What I do to one side, I have to also do to the other so that it maintains equality. So I'm going to be dividing both sides by 8/10. And then 15 divided by 8/10 gives me 1875, which would mean 1875 is the cost of the shoes at the department store. So that's from yesterday. You were really using a percent equation already yesterday. The process in general, you want to decide, is it a markup, a markdown, or a percent of? That's really important still. If you need to, you're going to add or subtract the percents from 100 or to 100. You would add it to 100 if it's a markup, subtract it from 100 if it's a markdown. You convert your percent to a decimal. This is very important. In a percent equation, we always write the percent as a decimal. And then you multiply to solve. Let me show you 3 examples. In our first example, they took a survey of 45 students. 20% said that they stay up past 10 p.m. How many of the students stay up past 10 p.m.? So first, is it a percent of, percent markup, or percent markdown, like an increase or a decrease? Well, they only want to know 20% of the 45 students that they interviewed. So if I imagine the model just really quickly, they had 45 total students, that was 100%. I just need to know 20% of it. So here I don't need to add or subtract anything with the percents. The way I approach it then is I rewrite it as like a little sentence. 20% of 45 is what? And we don't know. So it's going to give us some number of students. So I'm going to use an S there. Now I need to convert the percent to a decimal. We know that to do that, I would just divide by 100, which gives me 2/10 or 20 hundredths. Saying of 45 means I am multiplying it by 45, and that's going to equal the number of students. So there you have your percent equation. Now we simply multiply the 0.2 or 2/10 times 45. That gives me 9. Therefore, 9 students stay up past 10 o'clock. Problem number 2. The dinner bill came to $25, and I'm going to leave a 15% tip. What is the total cost of the dinner? Now, total cost indicates to me that this is a percent increase, which means I'm going to be adding this 15% to the cost of the dinner bill. What is the percent I am paying for dinner? Well, I'm paying 100% of the cost of the dinner bill, which means to find the total percent in this case, I would have, and let's look at it in terms of the model first, 100% of $25, and I would add to that 15% of $25, which means altogether I'm paying 115% of $25. So 115% of 25 would equal, we don't know, it's going to equal the total cost of dinner. Let's convert our percent to a decimal. I'm going to divide by 100, which gives me 1.15. Of 25 means to multiply by 25. That equals the total. Now I'm ready to solve. So 1 and 1500ths times 25 gives me $28.75. This means the total bill with tip would be $28.75. And then let's do one last example. A video game is regularly priced at $50, but it's on sale for 30% off. So $50 is 100% of the cost. It's 30% off. They want to know the sale price here. So this is actually a percent decrease problem. Imagine the model. I have 100% of the cost, and I would be taking away 30%. If I take away 30%, what percent am I paying? Well, 100 take away 30 is 70%. So that means I am paying 70% of the $50, and that's going to give me the sale price. Convert your percent to a decimal, divide it by 100 of 50 gives me the sale price, and now I just multiply. That means the sale price is going to be $35. So please don't forget today, when you're doing your work in the Google Doc or Google Slides, show me what your equation was. Make sure that you make that clear, and also make sure you make your answer very clear.